Hello, Labas, Vilnius. I hope I got that right. It's good to be here. And as I just said in the video, I'd like to talk to you about accessibility, not from the point of view of laws or guidelines, but from the point of view of an engineer who wants to try and make things work for people who use assistive technologies. And I'd like to share some information that I hope will help you all do the same thing. You'll all be familiar with browsers. We use them all the time. We develop things for them on a regular basis. At the moment, just about, we still have 4 rendering engines, one from Microsoft, one from Google, one from Apple, and one from Mozilla. Of course, we're about to lose Edge HTML as Edge becomes a Chromium browser, but just about for the moment, we still have these 4 basic user agents that are part of our daily work lives. What you may not have come across are things called screen readers. They're a piece of software that people like myself who are blind use to access pretty much all technology. Laptops, desktops, mobile phones, all have screen readers available on them. On the desktop, for example, on Windows, you have an integrated screen reader called Narrator. There's an open source free screen reader, which is very good, called NVDA, and a proprietary paid-for one called JAWS. On Apple products, you have an integrated screen reader called VoiceOver, whether it's iOS or macOS. And even on Linux, there is the Orca screen reader. Android has one too called TalkBack. But today I'm going to focus mostly on the desktop platforms, Windows, macOS, and to a lesser extent, Linux. So in the past, screen readers and the browsers used to take an HTML document and they would go away and they would each do their own thing with it. The browser would build the visual rendering of whatever the HTML code said with the CSS. It would provide any interaction that was there by default. The screen reader would then go away and do exactly the same thing, but in complete isolation. And it would build something called a virtual copy or a virtual buffer of the page. And this was a replica of the original, specifically intended to let the screen reader user interact with it in ways that aren't available to anyone who doesn't use a screen reader. So Windows were the only screen readers in the 90s. There was one for Apple products back then, but they stopped making it in 97. So for a very long time, blind people were really only able to use Windows on the desktop. And as I said, it consumed the technology pretty much independently of the browser. And what it enabled people to do was very simply read the text content of a website and get some information that sounds like this.
Heading level 1 using the ARIA current attribute posted in link code things on January 14, 2017. It is common on the web for the current thing in a collection to be highlighted visually, but providing an alternative for screen reader users has often involved something of a hack. The link ARIA current attribute is intended to solve this problem.
So screen readers will take all the text content that's there in a web page and speak it to the user. So that's the basic way a screen reader works. It takes what you see on screen and it turns it into synthetic speech, so someone who can't see the screen can understand the content. By the time we get to the 2000s, Apple had introduced VoiceOver on its platforms. So we have screen readers on Windows and on macOS. But something else more interesting had happened. Screen readers had started using platform accessibility APIs to get the information they wanted. So instead of the browser passing the HTML and the screen reader passing the HTML, the browser still did the same thing. It passed the HTML document. But this time, it creates something called an accessibility tree. And it contains all the accessibility information that a screen reader needs to know about the HTML. The screen reader now just asks the browser for that information using the accessibility APIs. So it's a much more efficient relationship. Instead of 2 things going their separate ways, we've got a browser doing most of the hard work, and then the screen reader just asking the obvious question. What is this thing? How do I announce it to the user? How do I tell the user what kind of element or thing they're interacting with? Like screen readers, there are platform accessibility APIs on every platform. Windows actually has 3. It has MSAA, which it first introduced in the late 1990s. through to UIA, which came along with Windows 10. Mac also has its NS accessibility protocol, and there's the ATK ASPI protocol on the Linux platform. So again, like screen readers, like browsers, these things are available on pretty much every platform in common use. So what happens now when the browser comes across some HTML? Well, if we take the main element as an example, we write this in our code, just a simple main element to signify the main content area of a page. The browser sees that HTML, and it adds some information to the accessibility tree. And one of the bits of information is the role of that element. In that case, it's pretty straightforward. It's main. The screen reader then says to the browser, hey, what's this element do? What does it represent? It gets that information, and then it tells the user that they have entered the main region of the page, like this.
Main region.
Just as simple as that. That information comes straight from the HTML through the browser to the screen reader. We get the same thing with the nav element, only this time its role is navigation. And so the screen reader, when it asks the browser for information, can tell the user that it's a navigation region.
Navigation region.
And it happens for all elements. For lists, for example, the OL or UL element will tell the user that they're dealing with a list. But the browser will also count up the number of list items that are inside the list, and it'll make that information available to the screen reader, which in turn makes it available to the user.
List of 3 items. 1 do this. 2 do that. 3 do something else. List end.
And in the case of that ordered list, it's also picking up the sequential ordering that's just inherent in that particular type of list. It happens with headings, but here we get a secondary piece of information. Not only do we get the fact that it's got a role of heading, we also get some information about its state. In this case, that it has a level of number 1 because it's an H1 element.
Heading level 1.
And again, all that information just gets picked up from the browser by the screen reader and conveyed to the user. It works with form fields as well. So, for example, a checkbox. In this case, the checkbox is checked. So it has a role of checkbox. That's what it does. In this case, it has another piece of information, an accessible name, and that's picked up from the label element that's tied to the input using the for and ID attributes with the same value. And again, the screen reader gets all this information from the browser and tells the user.
I live in the UK checkbox not checked. Checked.
So it told them the label, I live in the UK. It said it was a checkbox. Initially, it wasn't checked. And then as it got checked, that change in state got communicated from the browser to the screen reader to the user as well. One quick last example, because it wouldn't be an accessibility talk if I didn't include a button element in here somewhere, is that if we use the button element, the information that the browser makes available is that it has a role of button. The text in the middle of the button element becomes its accessible name, the thing the screen reader uses to identify the button. And again, all that information gets to the user.
Play button.
And it's quite simple. We just hear play and then the button, the fact that it's a button. And at that point, as with all of these things, someone who can't see that it looks like a button or a checkbox or anything else has the information they need to know what to do with it. If it's a button, I can press it, I can activate it, I can interact with it. If it's a checkbox, I can check it. If it's a main element, I know I've reached the main content area of the page. Same with nav, header, footer. And all this comes for free with the HTML. Which brings us to the present and things that we're doing now. The truth is that we don't always get the opportunity to use HTML elements like they were originally intended to. Sometimes it's because we're using JavaScript frameworks that don't really output very good quality HTML. Sometimes it's because we want to create things that don't exist in HTML. There are no elements for tabs, tab panels, for example, but they're a pretty common interface type on the web. So there are good examples. And what we do when this happens is we tend to use div and span elements as our building blocks, as the primitives for the things we want to create or do. The problem is that div and span elements are what we call neutral. The browser doesn't make any role information or any other accessibility information available about them. So if we take the example on screen where we've got some div and span elements that are designed to look like a toolbar, and dare say they've got the JavaScript to make them function like a toolbar, all the browser says to the screen reader is, this is just a bunch of div and spans with some text in the middle. That's all the information. So a screen reader will just say this.
Bold. Italic.
Nothing else. It has no indication to the user that they can interact with this, that it's maybe got buttons or it's a toolbar. It's just flat text. The good news is that we can do something about this. We can use a standard called ARIA, Accessible Rich Internet Applications, to give it its proper title. And this is a specification from the W3C. 1.1 is the current version, and there are also some rules for using ARIA with the HTML as a host language. And what we can do with ARIA is just polyfill missing accessibility when we need to. One way is to use the role attribute, and there are more than 70 different values we can give this. Pretty much any user interface component you might want to design has got a role, whether it's something simple like a checkbox or a radio button, or something more complex like a set of tab panels, a progress bar, a toolbar, a menu bar. There are roles, sometimes one role on its own, sometimes many roles that work in combination, that can help you create these simple through to very complex interaction components. And then there are around 45 ARIA prefixed attributes, and these can be used to give characteristics or inform state of different elements. So, for example, we could use ARIA expanded to say whether a disclosure widget had been opened or closed. We can use ARIA-required to tell whether a form field is required. As I say, 40 odd of these that let us add in all the different bits of information. And between these two sets of types of attribute, we can start to make things that aren't accessible to begin with reasonably accessible. So if we start with a really bad use case, a span element that we're going to turn into a button. If we have just our span element, as I mentioned before, it has no native accessibility information. So the screen reader is just going to think that there's some text on the page and not a lot else. But we can start to change that. We can use the role attribute with a value of button. And now in that construct, the accessibility tree that the browser creates, this span is going to be presented as a button. It's still a span in the DOM. So for those of you who do a lot of JavaScript work, you're still dealing with a span element. That node will look exactly the same. Nothing will have changed there. What will have changed is the way this element is presented in the browser's accessibility tree, where it will now, if the screen reader asks, be presented as though it were a button. We can use tabindex with a value of 0, and this will make the span focusable with the keyboard. Span and div elements are inert. You can't focus on them with the tab key, which is the typical way a keyboard user will interact and navigate through content. So tabindex with a value of 0 makes this thing accessible, and it puts it into the tab sequence, the order that someone will tab key through the page, based on the element's position in the DOM. So it's a very natural way to make something focusable. We then have to add in some interaction. We have to add in some click interaction, of course, because a span doesn't do anything by default. But we also have to add in the expected keyboard support. There is an expectation from keyboard users that the space or enter key can be used to activate the button. So we listen out for the key codes for space and enter, 13 and 32, and we make sure that we attach whatever functionality the button needs to do to both those event handlers for mouse and keyboard. And then what we get is a button that actually looks remarkably similar and sounds remarkably similar to the native button element we saw before.
Play button.
In fact, it's pretty damn impossible to tell the difference. It's still announced as play, because that's what the button will do, and the fact that it's a button. So we've been able to recreate the native equivalent of a button element using ARIA and some extra JavaScript. There's something that's missing though, and that's in both of those demos of the button element. When the button was pressed, the visual appearance of the button changed. But that wasn't communicated by the browser to the screen reader, so a blind person was completely unaware that the button had been pressed, toggled on or off. Here's where we can do that extension part of accessibility. We can use the ARIA-pressed attribute to indicate to the user whether the button's been pressed or not. If we set it with a value of false initially, when the user gets to the button, they'll now be told it's a toggle button, because you can toggle it on or off, and that currently it's not toggled. We then, of course, just need to make the whole thing work, so we need to add this into the functionality. When the button is pressed, as well as making the button do whatever the button is supposed to do, we flip the state of the ARIA pressed attribute. We change it to true when the button is pressed, and then we flip it back to false when it's pressed a second time. There's something else quite neat we can do, and that's to tie the visual styling to the state of the ARIA pressed attribute. This is just a nice way to hook things together, and it's really useful for bug testing. If the ARIA pressed attribute state hasn't changed, using a CSS attribute selector on that attribute means that if the accessibility isn't working, then the visual design won't work either. That change in appearance won't happen. So it's a good way. If your visual styles aren't working, it's a nice way to hook it back. Go and have a look at the accessibility, the state of the ARIA pressed attribute, and see if that's where the problem lies. And what we get then is a demo that sounds a little bit different from the other examples.
Play toggle button not pressed. Pressed. Not pressed.
And just by adding that one attribute in, the user who can't see the button and the way that it changes visually now knows when it's been pressed, when it hasn't been pressed, and right up front they know that it's a toggle button. And again, all this comes from just the HTML with a little bit of extra ARIA thrown in for good measure. I have to tell you, though, starting with a span to create a button is a really, really bad idea. We can get to the same point in accessibility terms as we've just seen, but there's a lot of extra code. Instead of using a button element, a mouse, event handler, and letting the browser automatically supply the keyboard functionality, we had to start with a span, add the role attribute, the tab index attribute. We had to provide all the functionality, both for keyboard and the mouse, and we had to, throw a lot of extra code at it for one tiny little button. Okay, it's only a few extra attributes, but if we scale that up to an entire web application, we can suddenly look at adding maybe 20, 30% more code and a lot more moving parts, and that makes code brittle and easier to break. So again, it kind of comes back to the idea, as much as you can, whenever you can, using HTML original elements is just a hell of a lot easier from a development point of view, if not from the user's point of view. We're also now at a time where we're increasingly seeing custom elements and web components being developed. They're an interesting idea. They're going to let us share code much more easily and also use kind of new elements or new ideas much more readily. And so we can transfer our button into a custom element. And here we're just going to extend HTML element. That's still the best way to create a custom element at the moment. You can, if you wish, choose to extend specific HTML element types, but browser support for that is still pretty patchy. Yes, you can go down the polyfill route, but again, coming back to the idea of the least complicated solution you can find is usually the most robust and resilient. So we do that, we set up a shadow root, and that's where all the makings of our toggle button are going to go in. And then lastly, we just set it up so that our new custom element will be called toggle-button. Custom elements, if you're not aware, have to have a dash in the middle of their name, just as an easy way to separate them from original HTML elements. So we can extend that and then into our constructor. We just add in the code to create a button element. We'll take the text from inside the toggle element as it's written into the HTML, and then we'll create our toggle button on the page. We'll instantiate it on the page. The functionality looks pretty much exactly like it did in our other custom component. We do the same thing. We flip the state of the ARIA pressed attribute, so we get that same visual setup related to the accessibility state, and that's all communicated to the screen reader. So it's really just lifting and shifting exactly the same code, but putting it inside a custom element this time. This means that now we can just write something simple like this. Toggle-button, open the element, put play in the middle because that's the text of the button, and then we close the toggle element. So the HTML loses a lot of the attributes. There's no tab index, no ARIA pressed in there. The code at the HTML level when we write it is a lot cleaner and a lot more simple. And then we get a button that, again, looks pretty much like the last one.
Play toggle button not pressed. Pressed. Not pressed.
And of course, because it's a custom element, we can use this as many times on a page as we want. So it's much easier from an authoring and development point of view. But there is a catch, and that's that if you were to look at that button in the DOM, you would still see the ARIA pressed attribute turn up there. And that's because at the moment, custom elements still leak accessibility attributes into the light DOM, into the DOM that we're all used to using. Any other attributes that we set in there are tucked away. They never get seen in the light DOM, but ARIA attributes still leak out sideways. And that's not a terrible problem, but one of the best things about the custom elements specification is the idea of encapsulation. It's supposed to protect things. Things that are written inside the shadow DOM are supposed to stay there, and things that are outside in the light DOM are supposed to stay there. And this kind of crosses that boundary in a bit of an ugly way. So it's something that people are trying to work on stopping. And that takes us to the future in accessibility mechanics. There is a specification being developed now called the Accessibility Object Model, AOM. It's very, very new at the moment. It really doesn't have very much in the way of implementations, even behind the flag. I think Chrome may have a few bits and pieces behind the flag just recently, but that's about it. But it's a JavaScript API that for the first time will let us as developers have access to the browser's accessibility tree. So up until this point, the browser's created the accessibility tree with all the information about roles and states, but the only things that have had access to that accessibility tree are the browser and assistive technologies like screen readers. With this API, for the first time, we'll be able to get at it as developers. And that opens up some enormous potential, some great possibilities for solving problems, but also some pretty scary questions that we need to think about very seriously too. So phase one is going to be ARIA reflection for attributes and elements. So the AOM takes all the ARIA attributes, and it means that instead of writing something like element.setAttribute, open parentheses, and then the name of the attribute and the value you want to give it, we can do something much more familiar in terms of our code. We can do element.role equals button, for example. So it's a simple change, but it puts accessibility information into a more familiar syntax that we're used to using in the rest of JavaScript. This is the bit that is being implemented in Chrome behind the flag and will probably be the first to come to other browsers as they go through it. Phase 1b will give us as developers the idea to set immutable default semantics through something called the element definitions object. So when an element is instantiated on the page, or a custom element is, we'll be able to set certain accessibility properties at that time. It's also going to give us the opportunity to change accessibility characteristics of a custom element or a web component in response to user interactions. So for example, when our toggle button is pressed, it'll make it easier and neater for us to change the state of ARIA pressed and have that kind of state communicated in the accessibility layer. Phase 2 is going to introduce some user action events. We have familiar events to all of us, mouse events, keyboard events, even touch events. But there are a few that are missing that are very important to accessibility. Doing things like scrolling up, scrolling down, increment up and increment down. This one is particularly important because at the moment, if you're talking about a web-based component that requires you to increment or decrement, to flick up or flick down to change the value of something on a touchscreen device, you can't do that accessibly on mobile when you've got the voiceover screen reader running on that device. So there is a fairly big problem that needs to be solved, and this phase aims to solve it. Phase 3 will give us virtual accessibility nodes. So this is where it gets really interesting. We'll be able to add nodes to the accessibility tree ourselves. So we'll be able to put things into the accessibility tree that are available only to screen readers. They won't exist in the DOM, they won't exist in the visual rendering of the page. It will be very much exclusively a non-visual screen reader only piece of content or piece of interaction. This still needs a lot of specification. It's not really clear how much we're going to be able to do, what kind of element or control or content we're going to be able to add, but this is the long-term goal. And lastly, 4, we're going to have access to the computed accessibility tree. So in the same way we can get access to the computed styles, we'll be able to get hold of computed accessibility information, and that includes any virtual nodes that we've added to the accessibility tree ourselves. So as developers, I'm fairly willing to bet you're all thinking, this sounds like a great idea. We can do lots to make things more accessible with this possibility. And you're absolutely right. But the scary question that I mentioned is privacy. Because the accessibility object model deals with ARIA, because ARIA is really only consumed by screen readers, when you start using the AOM, it's going to become possible to detect that the person using the website is using a screen reader. And the overwhelming majority of people who use screen readers are blind. Not all. Some are dyslexic or have other reading difficulties, but most of us are blind. So what we're going to end up with is a situation where it'll be possible to fingerprint that someone is using a very specific kind of assistive technology that is almost always used by someone with a very specific kind of disability. And that's an enormous concern to privacy. Not for all the people like yourselves who will probably use this technology to make better, more accessible experiences, but to all the people behind advertising who will delight in knowing that the person consuming their advert at the moment in time has a disability and tailoring their advertising to it, or doing other, even perhaps darker and more unreasonable things. And that's why I say this is the question that we've really got to think about. The AOM is being developed by the W3C. They're doing all their work on GitHub at the moment, which means we as engineers and developers can be part of that conversation. And I really encourage you to go and look up this spec on the W3C. It's somewhere called the Web Incubator Community Group. And if you've got questions, if you've got ideas, if you've got thoughts around any of it, the technical or the privacy, please add your voices in. That's incredibly important that the W3C and the people in the browser companies working on this specification hear from people like yourselves who are ultimately the ones going to be using these technologies when they're released in the future. So really, my message is to get accessibility right, you need to be a time traveler. We need to use the best of the past, as much native HTML as we can possibly get away with, because it's easier for us and better for accessibility. We need to be real about the present. We do use JavaScript frameworks. They are all pretty lousy in terms of the HTML they put out. That's not going to change the fact that we're still going to use them. So knowing how to polyfill that missing semantic information is incredibly important. And then being part of the future, adding your voice and your comments to specifications as they're developed is incredibly important because, as I said, it's you and me that are going to be using these specifications when they get released into the wild. So before that happens, that's the time to make your voice part of that conversation. Thank you very much. That's you.